While kids across the country will wake up tomorrow looking for gifts under the tree, NASA is hoping to celebrate with its own Christmas present a little higher up. The launch of its next generation space telescope is slated for tomorrow morning, setting up an unprecedented window into the cosmos. As science correspondent Miles O'Brien tells us, NASA is hoping to unlock mysteries of the universe.
Folded up and tucked in tight, the largest space telescope ever built is poised to launch a new golden age of astronomy. The James Webb Space Telescope is billed as the scientific successor to the Hubble, which has rewritten the textbooks over the past 30 years.
I like to say that James Webb Space Telescope can go where no Hubble has gone before.
That's astrophysicist and former NASA astronaut and associate administrator John Grunsfeld. We met him at the Kennedy Space Center Visitor Complex, where the shuttle orbiter Atlantis is now on display. Grunsfeld flew on it to service and upgrade the Hubble in 2009.
Liftoff of Space Shuttle Atlantis.
It was the last of 5 such missions for NASA astronauts.
I'm usually not inclined to anthropomorphize satellites or space shuttles or other things, but I really do feel a personal affinity to Hubble.
Grunsfeld was on 3 telescope servicing missions, making him history's most experienced Hubble repairman.
It proved the existence of black holes. It measured the age of the universe. It peered inside regions where baby stars are born and planets form. It discovered things that we never imagined were there.
Webb is designed to be about 100 times more powerful than Hubble, primarily a visible and ultraviolet light observatory. Built by NASA and the European and Canadian space agencies, Webb was first imagined in the late 1980s. It will scan the cosmos looking for sources of heat in the infrared part of the spectrum. For astronomers looking deep into space, this is where the real action is. John Mather is the senior project scientist for Webb at NASA's Goddard Space Flight Center in Greenbelt, Maryland.
The universe is known to be expanding. We've known this for almost a century. The distant galaxies are running away from us, and what that means is the wavelengths that we get from them are longer. So the farther out you look in space, the more stretched these waves are, the more infrared they are. So to see farther than the Hubble can see, you have to have a telescope that can pick up the longer wavelengths.
What do you think Webb will find?
The Webb is so powerful. If you were a bumblebee hovering at the distance of the moon from Earth away from the telescope, we would be able to see you. So, if you're out there, we'll find you.
But getting Webb out there to its perch in space is a tall order. It will lift off from French Guiana on an Ariane rocket built by the European Space Agency. A few days after launch, the telescope is slated to start unfolding origami style. It's an intricate 2-week deployment filled with mission-threatening Achilles heels. In space parlance, single-point failures. Bill Oakes is the project manager. Have you counted up how many potential single-point failures there are?
We have 344 single-point failures.
The biggest worry is the deployment of the sun shield. The size of a tennis court, it consists of 5 uniquely shaped layers of a material called kapton. Not unlike a mylar balloon, the reflective material is thinner than a human hair.
When we get through that, we'll be able to take a deep breath, have to keep moving forward, but at least that's 1 down, and that's hopefully will be the hardest thing we have to deal with.
So you guys are like Carl Wallenda, no net.
Yeah, there's no net. No net, it's not serviceable. It wasn't designed to be serviceable like Hubble.
That's right, John Grunsfeld won't be visiting this space telescope. It is headed 1 million miles away to a spot in space where it will orbit the sun in sync with the Earth. It's the sweet spot for Webb because the gravitational forces there will keep it more or less in place. And it is very cold, important for a telescope looking for the faintest hints of heat at the farthest reaches of the universe. Amber Strawn is the deputy project scientist for Webb Communications.
Everything glows in infrared, like you and I are glowing in infrared. And a telescope, even in low Earth orbit, would glow in infrared. And so we need to have this telescope out in deep space so it gets very, very cold. So in essence, it's not glowing and seeing itself. It has to be cold so it can see the infrared signals from the distant universe.
They have tested the telescope every which way they could imagine. They have shaken it and exposed it to loud noise to mimic a launch. And they have turned it on in a giant Apollo-era thermal vacuum chamber at the Johnson Space Center in Houston.
Discovery, go for Hubble release.
The Hubble experience looms like a nightmare. It was infamously launched with a flawed mirror, rendering the telescope terribly nearsighted until it was corrected 3 years later during the first Hubble repair mission. Greg Robinson is the Webb program director.
Do you feel pretty confident this telescope is not going to be flawed from the outset?
We try to test exactly the way it's going to be used in its launch and operational environment. It's been tested well. We have margin around how we test it, so we have high confidence that it'll work just right.
The novel design, rigorous testing, and the vagaries of NASA budget allotments led to years of delays and cost overruns. At $10 billion, the price tag for Webb is about twice as much as first proposed 2 decades ago.
What would NASA do differently today?
We do have to get better at cost and schedule estimating up front with these type missions, and it's not trivial. It's quite hard. We're doing things that have never been done before. We're using new technologies, never developed or flown before. So it's more of a challenge.
All of this ratchets up the pressure on the team.
We have to get this right. It has to go right the first time. We can't go fix it. So there's absolutely a lot riding on this telescope. The future of astronomy is riding on this telescope. It's a huge investment. I believe it's going to work, and I think it's going to be a huge payoff in terms of what we learn about the universe.
I think the universe has a few surprises in store for us. We don't know what questions to ask because we've never had a capability like James Webb.
If all goes well, Webb will be focused and fully commissioned 6 months after launch. After that, it promises to open our eyes to the most distant past, to the nursery where newborn planets first emerged 13 billion years ago. For the PBS NewsHour, I'm Miles O'Brien in Greenbelt, Maryland.
Don't forget to tune into that launch tomorrow at 7:20 a.m. Eastern. You can watch it live at pbs.org/newshour.